Hello friends, a warm welcome to our next session on instrumentation and control in power plant industries. Many a times while instrument selection we come across the question whether to choose an RTD or a thermocouple for our specific application requirement. Friends, just by looking at RTD or a thermocouple, it's very difficult to distinguish between the two. The physical appearance both look alike. Both RTD and thermocouple are widely used in power plant industry for temperature measurement. Although from outer appearance both RTD and thermocouple look alike, but both are quite different in terms of their working principle, their temperature measurement range, their accuracy of measurement, the response time to show the corresponding temperature change, and finally the important factor that is their cost. So depending on your specific application requirement, you may choose the best fit out of RTD or thermocouple where you need the temperature measurement. Hope by the end of this session, we would be able to clearly understand where to use an RTD and where to install thermocouple. Friends, coming to the difference between the two, so our first difference is their principle of measurement. An RTD works on the principle of predictable change in resistance of metals on their temperature change. Means if we heat the metal like platinum, nickel, or copper, their electrical resistance increases with their increase in temperature in a predictable manner, generally in a linear manner. Then this change in resistance is converted into a corresponding voltage signal using a measurement circuit, either a Wheatstone bridge or a comparatively better circuit which is constant current source circuit. Thus, this measured voltage is calibrated to get the corresponding temperature reading. While our thermocouples is based on the change in electromagnetic force, that is EMF, corresponding to the change in temperature. As we can see in this picture, a thermocouple is made up of two dissimilar metallic wires joined together at one end. This end is exposed to process medium whose temperature is to be measured. This junction is called hot junction, whereas the other end of these metallic wires is called cold junction, and voltage is measured at this end. This generated EMF is very small in millivolts, generally up to 25 to 30 millivolt. Then this measured voltage is calibrated to get the corresponding temperature reading. So this was the difference between their working principle. Now coming to their measurement range. Our most commonly used RTD in a power plant is Pt100, and Pt100 RTD can measure from a very low, that is minus 200 degree Celsius, to a high up to plus 850 degree centigrade. While thermocouples can be made up of different metal combinations and thus can show different application range. Our chromal aluminum thermocouple, that is our K-type thermocouple, is the most commonly used thermocouple in power plant industry, and it can measure from a very low of minus 200 degrees centigrade to a very high up to plus 1250 degrees centigrade. Whereas for a very high temperature range, such as in a furnace, we use type C thermocouple made up of tungsten rhenium to measure up to a temperature of plus 2315 degrees centigrade. So, measurement range wise, thermocouples have a wider measurement range from minus 200 degrees centigrade to plus 2315 degrees centigrade, while RTDs have a measurement range of minus 200 degrees centigrade to plus 850 degrees centigrade. Clear? Now coming to their accuracy, RTDs have better accuracy than thermocouples. RTDs may have an accuracy of plus minus zero point 0.1 degree centigrade, and this accuracy is almost constant. Friends, we know accuracy is generally defined in terms of error in measurement. So lesser the error, the better will be the instrument. While thermocouples have comparatively poor accuracy than RTD, their accuracy may vary from plus minus 0.5 degrees centigrade and may go high up to plus minus 5 degrees centigrade with temperature change. Means while measuring temperature in minus or while measuring very high temperatures, thermocouples may show a high error in measurement. So we can say RTDs are more accurate as compared to thermocouples. Clear? So accuracy wise, RTD wins. Range wise, thermocouple wins. Now, next coming to their response time. So if we talk about the response time, friends, response time is how fast they can sense the temperature change and can show the corresponding change in temperature reading. The response time of RTDs is generally slower than that of thermocouples. RTDs may have response time from a few seconds to few minutes, whereas thermocouples, on the other hand, have a much faster response as compared to RTDs. Thermocouples have response time in microseconds or even in means can go up to milliseconds. So in terms of response time, thermocouples are much faster than RTDs. Now coming to the cost, we know RTD, our most commonly used RTD is Pt100, that is platinum 100, and it is made up of platinum, which is a costlier metal. So definitely the cost of RTDs is comparatively higher than the cost of thermocouples, whereas thermocouples are made up of cheaper metals as compared to platinum, and thus their cost is less. So cost wise also thermocouples are better. Means till now we have seen that accuracy wise RTD is better, then measurement range wise thermocouples are better, response time wise these thermocouples are better, cost wise thermocouples are cheaper. One more thing, if a temperature measurement is used for overall plant protection, for example our HP main steam temperature or reheat steam temperature, where a very high temperature can increase the stress level on the main steam piping, we may have to either initiate a gas turbine load reduction, or in worst case we may have to initiate our GT and HRSG shutdown. So then it is advisable to use thermocouples due to their faster response time. Clear? Means if if it is a concern of overall plant protection, then it's better to use thermocouples. Whereas for individual equipment protection, such as our pump bearing and winding temperature measurement, the change in temperature itself is not very fast, but means we have to protect our pump. So an more accurate instrument is required. So we use RTDs due to their high accuracy to protect our pump. A single pump failure generally initiates either the standby pump startup, or if standby pump is not available, then at max it can bring the plant to part load. But our costlier pump is safeguarded and can again be taken into picture after its maintenance. So friends, if we summarize measurement range, RTDs have minus 200 degrees centigrade to plus 850 degrees centigrade. Thermocouples wider range, minus 200 degrees centigrade to 2315 degrees centigrade. Accuracy wise, RTDs are much more accurate than thermocouples. RTDs accuracy is plus minus 0.1 degree centigrade and thermocouples is plus minus 0.5 degree centigrade to plus minus 5 degree centigrade. Response time wise, RTDs are slower, few seconds to minutes, and thermocouples are much faster. either means from microseconds may up to milliseconds. Cost wise, RTDs are costlier due to platinum cost, and thermocouples definitely cheaper than RTDs. So friends, to summarize, for an instrument selection out of the thermocouple and RTD, first we have to look at the process temperature range, which we have to measure. Then we have to make a judgment based on the accuracy requirement and the budget. If we need higher accuracy, then we use RTDs, and if we need cost-effective solution where slightly lesser accuracy can be accommodated, then we should go with thermocouples. So friends, I hope now we are clear where to use an RTD and where to use thermocouple for our requirement. Hope I am able to clear the concept well. Your valuable feedback is most welcome, so please share your feedback in the comment section. We will meet again in our next video. Till then, stay safe, stay healthy, take care, bye.